Good morning. Thank you and welcome to another webinar, TAGO webinar. Today we'll be speaking about the polarimeters in the cosmetic industry. This is the temperature controller edition because we're gonna kind of touch polarimeters in the cosmetic industry, but we're gonna focus a bit more on the temperature control side of taking readings with the polarimeter. Okay. So, polarimeters are commonly used in the cosmetic industry for raw materials and additives and other things. Polarimeters are widely used to test and measure the concentration of optically active substances. So, unlike refractometers, where everything has a reading, whether it's water or any type of liquid has a value in refractive index or Brix. With polarimeters, not all substances or liquids have a value or a reading. It has to be optically active. We covered that in a different webinar where we spoke about the polarimeters and the chiral molecules. So we're not going to cover that here, but I did want to mention that not all liquids, not all oils that you use in the cosmetic industry have are optically active. So polarimeters are used only for the optically active, or only when you're using optically active substances. Some of these optically active substances are essential oils like camphor oil, like natural oils, or even perfume bases. Also, polarimeters are used for amino acids. Amino acids like glyceric acid and I'm gonna butcher this one, tryptophan. We're going to talk more about tryptophan, or at least we're going to mention tryptophan more later on. Polarimeters are also used for other ingredients. So here we spoke about raw material and additives, more as in the incoming or receiving of these raw materials and additives to check their concentration. Here we're talking more about the production side. So this is more like a quality control of receiving these materials and raw materials and additives. This is quality control of production. Because sometimes you want to add property to your product, whether it be a toothpaste or cream. An example of these properties are if you want to make a cream that is has moisture retention, so it helps with moisture retention. Panthenol is often used as a moisturizer because of its properties. But it can also be used for as a soothing or anti-irritant agent. Panthenol, since this is the example we're using, comes in two different types: D-panthenol and L-panthenol. And the D-panthenol is the one that is optically active, but there's also one that is a mixture of both D and L, which is the D and L panthenol. So a polarimeter is used in this example to measure how much panthenol your product has, if that's what you choose to use. So that was just an example of a specific use of polarimeters for ingredients that would change or add to the property of your product. But like I said before, we're going to focus a bit more on the temperature control side of polarimeters. So temperature is one of the biggest factors in getting accurate and repeatable results, because unlike refractometers where some substances can have a temperature temperature compensation. For example, Brix has a temperature compensation. With polarimeters, there is no temperature compensation for angular rotation or for optical rotation. There is a scale that is temperature compensated, but that's mostly used in the sugar industry, not in the pharma or cosmetic industry. So if you don't have temperature compensation, then controlling the temperature of the sample is very, very critical. Because if there's a slight difference in the temperature, there's going to be a slight difference, or there's going to be a difference in the result, in the reading. So the more accurately the temperature is controlled, the more accurate and repeatable the result is. Okay. So if you're not using temperature control, if you're not controlling temperature for your polarimeter readings, then you might be having a wider repeatability than you should, or than you would if you were controlling temperature. Here we have an example of different substances that were measured on a polarimeter. The blue bars are no temperature control at room temperature, and the red bars are with temperature control at 20. So the numbers at the top, numbers here, are the repeatability of the reading. Okay, so let's jump to tea tree oil, for example. The blue bar is no temperature control, so that was giving about 0.01 more or less, no, about 0.12 repeatability. But when the temperature was controlled at 20, you could see that it went down by a lot. Repeatability improved by a lot. For butcher this one, for tryptophan, the difference was not as much. It was improved, of course. The more you improve temperature, the better. But for some substances, as you can see, same thing with threonine, there was improvement, but just slight improvement. But for tea tree oil, for L-glutamine, for menthol acetate, there are huge differences or huge improvements in reading. So that's how much, just visually showing how much you can get an improved reading when you use temperature control. Now, this is just speaking about temperature control in general. There are many ways to control the temperature. We're going to see the traditional way in a bit, and also the new way, which is well, not new, but kind of new, which is the temperature control by Peltier. Okay, but this chart just speaks in general controlling the temperature. Okay, so I mentioned those substances before. Tryptophan is used for hair or skin conditioning. Threonine is for protein balance. L-glutamine helps with the collagen production, and L-ascorbic acid is an active vitamin C. These are just popular substances that are used in the cosmetic industry. From measuring 19 different substances, we saw that improved repeatability or reproducibility was 95%. So there was a 95% improvement in repeatability when controlling temperature. As I mentioned before, and as you can see from the chart, some substances have slight improvement, some substances have huge improvement. So it is based on the improvement that you get by controlling temperature does vary by what substance it is. Okay, and here we're talking about the two types of controlling temperature for polarimeters. To the right, you have what would be your traditional type, which is a water bath and a flow cell. So you have a cell that has liquid running through it or around it, and then you pour your water, liquid. Yeah, so you have some cooling agent, whether it be water, ethylene glycol, propylene glycol, or some type of alcohol that's coming through these tubes and is circling around this tube. You would pour in your sample or inject your sample through here, either through the funnel or inject it at this base. So then your sample would be surrounded by the temperature of this water bath, which is circulating liquid around your sample, and that's how temperature is controlled. That's the traditional way. The other way is when the Peltier is used. Peltier is mostly used in, well, not mostly, refractometers use Peltier a lot for temperature control. It's one of the most commonly used styles of controlling temperature, and it has come to the polarimeters as well. The benefit of using Peltier temperature control is time. The Peltier is a lot quicker than the water bath, especially if you're counting at the beginning of the day. So if you're coming into your lab, your water bath has been off all night, you turn it on and you have to wait for your water bath to get to its target temperature. Then you have to connect to the polarimeter, and then you have to do minor adjustments to your water bath so that it's reading around the cell, it's reading the temperature you want it to be. So the setup, the wait time is a lot in the morning if your water bath has been off. If you went out to lunch and come back and your water bath has been on the whole day, it's very quick. But if you're starting from scratch, then you gotta wait a lot with the water bath. With Peltier system, it's very quick. You turn on the Peltier, you put in your target temperature, and within seconds, it's there. Okay. Also, you have more control over the accuracy of the temperature, the resolution of the temperature, and especially here in Japan. I'm not sure if you visited, but a lot of the real estate is small. The apartments are small, the restaurants are small, the labs are small. So the water bath system takes up a lot of real estate or a lot of space on your desk or below your desk. The temperature controller, which is the Peltier, does not. It's very small. And the Peltier system temperature controller is very easy to handle. It's small, easy to use. The water bath, you're dealing with hoses that are bringing in liquid. If one of them pops up, then you have a mess in your lab. So the temperature controller is quicker, it's more accurate, it's smaller, and it's easier to use. Okay. And well, more about the temperature controller. It's adaptable. If you have a Polax 2L, if you have an AP100, which is a discontinued polarimeter that's still in the market, discontinued because it's so old. But it's still in the market, people are still using it. AP300 or a Sakai. If you have any of these four polarimeters, you can install a temperature controller on your current polarimeter. If you're looking for a new polarimeter, then you can buy one of these with the temperature controller. But if you already have one, if you already have an Atago polarimeter, you can purchase the temperature controller and add it to whatever Atago polarimeter you currently have, whether it's old, discontinued, or new, it'll fit it. Okay, and not only that, the wetted material of the temperature controller comes in stainless steel, which is the most common metal out there for this type of application. But it also comes in hastelloy to meet the needs that you might have with some harsh chemicals they might need to measure. Okay, and well, let's jump to the video. We have a short video showing how to use the temperature controller, how easy it is, and some other details. So here we're gonna see, well, earlier I mentioned that the temperature controller fits Sakai, AP300, and Polax. This video that we're gonna watch is the Sakai setup. me see if I can run this up a little. Okay, so temperature controller, catalog number 5900. Temperature ranges from 10 to 50. So normally you're either reading 20, 25, or 30, depending on what the substance you're testing. The range of the temperature controller itself is 10 to 50 with an accuracy of 0.2. Okay. It's a thermal module. Sorry. It's a thermal module. So it fits it fits in your current polarimeter, whether it be Sakai, AP300, or Polax. And here we have the different parts of it. You have the base, which you just need to install once. You have a fan, because all Peltiers use a fan for cooling or heating. You have fan filter cover, and the 100 millimeter observation tube. Now we're going to show you how to install it. You just, for a Sakai, you just bring down the cover. You install the bars. Well, I'm sorry, talking about the channels. You have two temperature channels. One is testing the temperature of the chamber. The other one is where you would connect the temperature controller. So here you see me connecting the temperature controller to the Sakai. This is so that the temperature controller can report the temperature to the Sakai for readings. And that's the base that I'm installing. That's it, you just pop it in. That's all the installation you need. Then you would fill up your flow tube and put it on the base, and then put on the cover. And that's it. That's how you install it, that's how you put it in. Just make sure the wires are not in the way of the path. And that's it. It's easy to use, easy to remove, easy to clean. This is the same way. A different setup. It's the same way. So you can set it outside the Sakai, and then take it as a whole, and then put it in. So it's just showing you two different ways of setting up the temperature controller. Okay, and then you turn on the Sakai. Go to measurements. On the top right, you see the temperature. Here I'm turning on the temperature controller. Temperature controller has a different module on the right of the Sakai. That's where you control the temperature. The displayed temperature is not the temperature of the sample. The temperature of the sample, you see it there to the left, is the temperature of the sample. So you will control the temperature of the controller until the Sakai displays the temperature you want the sample to be. Okay, so let's say you want the sample at 20, but my room temperature is maybe 25. So I might need to set up my temperature controller at 18 or 19, 19.5, so that my sample is 20. Okay, if your room is 20, then the temperature controller might only need to be 20. So it all depends on the ambient temperature and how the ambient temperature affects the sample or the reading. Okay, you can see how quickly it goes from 25 to 20 Celsius. And I have programmed this one for 19.8, was it? So that the sample to the left of the screen, it hits 20. Okay, so sorry, I had put it at 20, but the sample only read 19.5, so I changed it, and now it hits 20. Okay, then it's ready to take a reading, just like the regular polarimeter. You press start, it takes a reading. And that's it. So that's the video of how to use it. We also have a video for the AP300, which is used very similarly, and one for the Polax or Polax 2L. So if you want to review these, just let me know and we can send you some more information on these. Okay. And for us, that's it. Thank you for attending. If you have any questions, please email us at overseas@atago.net. Thank you very much.